Welcome everyone. Yes, the second video, the part 2 of our discussion on measurement and units. And I have prepared a highlight of content we want to talk about today. Derived physical quantities is the first thing we'll be talking about briefly. Then we'll go to dimensions, the discussion on dimensions. We'll talk about the concept of position, distance, displacement. Talk about the limitations of experimental measurements. And then I'll see you in the next video. So let's start from derived physical quantities and units. Let's talk about that first. Now, we discussed in our previous video that fundamental units are those that are the building blocks of every other unit. And so derived units are particularly those we obtain. These are units obtained by algebraic combinations of the fundamental quantities. So these are quantities, rather. Let me put quantities. These are quantities and units, because we're talking about quantity and these are quantities and units obtained by algebraic combination of fundamental quantities and units. So for example, our regular area of a square is obtained by a combination of length times length, which is length square. So we combined the algebraic combination here is multiplication. Multiplication is the algebraic combination. In volume, let's say volume of a cuboid. It's a length times breadth times the height. You see that? Here it's also multiplication. Let's go to one random one that we know. I would say that is pressure. That is obtained force over area. Here, the algebraic combination is division. So that's how it works. For very, very, very random examples, you have different algebra. So your assignment at this junction is that I want you to find out 10 more derived quantities. Speaking of their unit is always also derived. For example, let's go back to the area of a square. We say that is length times length. The unit of this first one is meter times meter. We give us meter square. So the area of a square has a unit of meter square. Same thing applies to volume. Volume is length times breadth times height. Meters times meters times meters, giving me meter cube. So the unit for that is meter cube. Now keep in mind that for something like pressure, where we have force over area, unit of force, we'll always break it down first into the smaller one, into fundamental quantities. Let's break it down. Mass times acceleration. Then we have this one, we can call it length times length. But we already know, since we might not need to break it down. Let's just put, let's put area there because we already know the unit. We found that like meter squared. So now, for mass, we know that the unit of mass is kg. Acceleration, if I come to a corner and I want to get acceleration, acceleration is, I would say, velocity over time. And I know velocity is meter per second over time, seconds. Now, where did I get velocity to meter per second? Velocity is more like speed, related to speed, and that's like displacement over time. Now, there's a difference between distance and displacement. Distance is the one where you have speed, distance over time. But velocity is where you have displacement over time. Now, my goal of doing all this is to show you where that meter per second came from. Displacement is in meter, time is in seconds. So velocity is meter per seconds. Now, if you're very new to physics, don't be too worried about this. You might just know it from now. When we get to explain later as we go on, you'll get used to it. So some things about physics where I don't want to fear that when you come across something for the first time, just take it as fresh knowledge. I am aware. I've not been aware before, so I'm aware now. So, but don't feel like, oh, I'm going too fast. You will get to also get used to these things, and so you will know them. So, but for now, if it's a new thing to you, acceleration is velocity over time. And so velocity, since velocity has a unit of meter per seconds, then over seconds, that's eventually going to give us meter over seconds dot seconds. That's meter over seconds square. Now call that So yeah, I'll put for acceleration meter per second square over area is meter square. So that will give us a compounded unit for pressure. 1 m can go with 1 m here, so we'll be left with m. So we'll not be left with this unit, kg per meter per seconds square. So this in another nomenclature, we can call this, there are other units for pressure. Pressure is measured in, some measure in atmosphere, some measure in Pascal. Others just use the standard unit for force, and they say Newton per meter square. So keep that in mind as we learn. So, but just keep it in mind that derived units, most of the time, you have to work it out, just like we have gone step by step. So that's the discuss basic physics on derived physical quantities and units. Let's quickly move to the discussion on dimension. Dimension of physical quantities. And put that way. In this, when I'm teaching this topic, I'll be using, so I'm going to be the use of L, something like this, M. I might not be putting that bracket, so just keep in mind the letters and T. They are popularly used. Let's quickly brush through. Let's take, for example, I am asked to write the dimensions of velocity. I'll write it as velocity equal to distance over time. Now, for basic physicists, for now, you might be hearing people using it interchangeably, distance, displacement, all along. They want to mess things up. But I want to assure you that distance is not the same thing as displacement. So keep in mind that even though you see me for your basic level using it interchangeably, they are not the same. When we go further, we'll establish the difference between them, even maybe very soon. So, but just keep in mind, I would love to write the correct thing here, so I'm going to write it as a displacement. Even though distance and displacement are the same unit, it's meters. So we want to write the dimension of velocity. So whenever you want to write dimensions of quantities or anything, you break it down first. So we broke velocity down into displacement over time. And so before I go further, I'd love to establish that L that you see up there is a representation for length. M that you see up there is a representation for mass. And T is a representation for time. Now, displacement itself is a kind of length. So the dimension applicable to the numerator is L. And definitely time is obvious. The dimension applicable to time is T. So the dimension for velocity is going to be L per T. Keep that in mind. Keep that in mind. And your assignment is to try to do the dimensions for acceleration, dimensions for force, try the dimensions for pressure. So let's move straight to discussion on concepts of position. We won't waste time. Concepts of position. And here is where I will be establishing the difference between distance and displacement. And our focus is going to be distance. Focus of this discourse is going to be distance and displacement. Yes. Distance. I would say that is journey. I established initially that distance is just the interval between 2 points, like not events. Time is the interval between 2 events. But between 2 points, maybe on the body or on the surface or something, or in real world. But this point at this junction, I would love to define distance as journey. Let me call it the journey made between 2 points in any direction. And the difference between that and what we call displacement is that displacement, on the other hand, is the journey made between 2 points in a specified direction. So the distinctive word that tells you the point to draw a line of difference between distance and displacement, the word is direction. One of them has direction, the other one is directionless. So a way of saying that is that I can say, oh, for distance, I can say I moved or I covered 30 kilometers. But when you are speaking of displacement, I can't say it like that. I will say I moved 30 kilometers east of the bus. So there is a reference, there is an endpoint, and there is a trajectory. Trajectory is more like you can replicate that particular motion almost exactly. If I told somebody I moved 30 kilometers, let's say I moved from the center of somewhere now, and for instance, the radius is 30 kilometers. This place can also be 30. So if you don't specify, anybody can cover these 30 kilometers anyhow. But if this is a bus, and I say I moved 30 kilometers east of the bus, and since I said east directly, this is north, south, west, east. Let's just define the coordinates to be no. Let's arbitrarily define it that way. So now move like this. That's specific. So that established that discussion. I will quickly specify some things on your notes to say, okay, time, as I said before, time, as I noted earlier, the interval between two events. It's beautiful that I made mention of that. I'd love to know that speed is the time rate. Now, let me quickly discuss this. In physics, once you hear time rate, it's more like telling you that that thing is going to be divided by time. That is, it's going to be talking about how frequently that thing happens with respect to time. Per time. So speed is the time rate of distance. This formula for speed is distance over time. On the other hand, velocity is displacement over time. Acceleration is change of velocity with respect to time. So here we'll be representing final velocity as v, initial velocity as u, and the time as t, where that t can be t2 minus t1. So let me write it finally as v over t, acceleration. V is final velocity, u initial velocity, t is our time difference. Keep all of this in mind. So the discourse on give me a minute. Discourse on limitations of experimental measurement is that I want to talk about, under that area, I'll talk about percentage error, errors, and approximation. Errors focuses on difference between original value and the measured value. So we can put the formula for error to be absolute difference between original and the measured value. So when we talk of percentage error, we say it is the error over original times 100. So keep this formula in mind. This is where we'll wrap it up with this particular lecture. We'll be moving to another part of basic physics in our next video. Endeavor to subscribe and make sure that you do the assignments. Also, make sure you just go to the internet, get some quantities and practice how to break them down and apply some of the things taught. Rehearse. Physics is life. Life is beautiful with physics. I remain Peter Ofodo, your favorite tutor. See you in my next video. Thank you.